Hi, in this video I'll be talking about mesoscale circulations, which last from hours to days and has the size of about 20 kilometers. More specifically, I'll be talking about thermal circulations. Now, thermal circulations are caused by changes in isobars and pressure gradient. Isobars can be seen in the figure in the top right, where the three lines denote isobaric surfaces. This is at the north and this is at the south. The line nearest the surface is at the highest pressure, which is about 1000 millibars or 1 atm. Somewhere at 1 kilometers away from the surface is at a lower pressure of about 920 millibars. Because of differential heating between the north and the south, the isobar expand, creates a high pressure zone in the south and a low pressure zone in the north, and this creates the pressure gradient which moves the air from the south to the north. On top of that, because of the heating of the surface at the south, creates a low pressure air near the surface because warm air rises, and this replaces the air that has moved from the high pressure zone to the low pressure zone. Because of this movement of air, there is less air in the south, and this moves the air from the north to the south, which also creates less air in the north, and the air above it would come down to replace the air in the north. This movement of air from the high pressure zone to the low pressure zone, and the hot air rises and cool air sinks between the different levels of the atmosphere, creates the so-called thermal circulation. Now we look at the sea-land breezes. Like the thermal circulation is also caused by differential heating or cooling, but this is now between the adjacent land and water surfaces. This is how the sea breeze develops. Land warms, creating rising air and a thermal low. The cooler or denser sea air produce a thermal high, which moves in to replace the rising air. Air sinks over the water in response to this movement of air, and this produces the return circulation from land to sea breeze aloft. Next, we look at the development of the land breeze. Stronger nighttime radiative cooling of the land surface, which also means that the land cools a lot faster than the water cools in the ocean, leads to sinking and the offshore flow of this cooler air mass. And this movement of air produces the return flow from the high pressure zone aloft to the low pressure zone, which creates an opposite circulation as compared to the sea breeze. Another example of the mesoscale circulation is the mountain and valley breezes. Valley breezes blow uphill during the day, while the mountain breezes blow downhill at night. The nighttime downhill mountain breeze is sometimes called the gravity winds, or even the drainage winds, because of the way gravity causes the cool air to drain downhill. The valley and the mountain breezes are, just like the land sea breezes, caused by differential heating of the slope of the mountain and valley. The slopes are warmed by solar radiation, or solar heating during the day, and cooled by radiation at night. In the valley, during the day, it is cooler compared to the top of the mountain, and warm air of the sides of the mountain rises. At night, the slopes cool a lot faster than the valley, which causes the winds to flow downwards to the valley, and the hot air, the relatively hot air in the valley, rises up at night. This movement of air is caused by the differences in the pressure produced due to the differential heating. The valley breeze, or the daily wind cycle, is at its strongest on clear days when the prevailing winds are light.